do your eyes work? And when they don't work, how do spectacles help them to work? How does a microscope work? Or how does Galileo able to see faraway stars with a telescope? How does a camera work? All of these depend on a very simple convex lens, the old simple magnifying glass. In this unit, I'll give you some ideas of how you can help students to understand how images are formed in convex lenses. Without any fancy apparatus, we can get them working on what's effectively an optical bench, and through it understand how lenses work. And at the end of it, have some fun, show them how they can make their own telescope or their own microscope. Right, for the optical bench, what do you need? Well, a tape measure, dressmaker's tape measure, if you've got one. If you haven't got one, you make one. What do you need for that? Some masking tape. That's quite strong, but to make it stronger, you double it over and stick the two sticky sides together, and you've really got a very strong tape. Right, for your optical bench, all you need is your tape measure. For your convex lens, all we need is a magnifying glass. For the light source, all we use is a candle. Your flame should roughly come in the middle of your lens. We can pick up its image on a screen. Right, one of the first things that the students are going to need to know is what are the focal length of that lens that they're working with. And there's a very easy way, quick way to do that. The best is to go outside where the sun is, because the sun's essentially at affinity. So light coming from that sun is traveling parallel, and when it passes through the lens, it will focus at the focal point. And then we can measure the distance from the focal point to the lens. That gives us the focal length of the lens. But if we're doing it inside, there's another way in which you can do it. Instead of using the sun, you use the window. Hold the thing up in front of a screen, and by shifting it like that on the screen, you can get an image of the window. Then use a ruler, and the distance between the screen and the lens is the focal length of this lens. I've made this little gadget here, which makes it a lot easier because you can angle the screen to suit yourself. And it's exactly the same thing. Here's my screen, and by shifting it like that, I can get to the focus point. It's around about there. And so I can see here what the focal length is. And we can see that it's roughly 19.3. Now, the basic tool that the students are going to use to have a look at the formation of images is just the candle, the lens, and the screen. Make sure that the candle fits roughly in the middle of the lens in terms of height. Move that out to whichever distance you want, and then on the screen, we move the screen, and you can find that at a certain point you'll pick up the focused image of it. Have a look at the nature of the image, and they can see, well, it's upside down. It's small compared to that. So it's a diminished and inverted image. And what's more, the light rays are actually there. They're falling on the screen. We call that a real image. And they need to know that's real as opposed to a different kind of image, which is the virtual image. Right, before we go into the activity, I just want to talk to you about a very important part about science teaching. And that is the way in which scientists work, and therefore the way in which you should try and get your students to think and start working as well. And one of the major things that scientists do is they investigate, collect evidence, data, and that sort of thing, is they try and look for patterns in the results and the data, look for relationships, and out of it try and come up with a generalization or a general rule. If they can get that general rule about whatever it is they're studying, they can then apply that to other lenses that they might be working with or whatever have you. And in that way they can predict, and that's very powerful because they can predict behavior. They don't have to first go and discover it. In this experiment, we're going to get children to look at the images formed by convex lenses. In this case, I've got a lens. It's got a focal point of just under 10. So there's its focal length, and that's twice the focal length. So depending on what the focal length is of the lens, depending on where you place it in relation to its focal length, you can predict where you will find the image. You can predict how big that image is going to be. You can predict whether it's going to be upside down, whether it's going to be the right way up. That all should come out of their investigation. They've found a general rule which they can then apply. Once they've done that, you give them another lens and ask them to use that lens to test their prediction. Okay, up to this point they've been doing things qualitatively. They've worked out a general rule, put the object here, you'll find the image there. Of course they can do the thing quantitatively and investigating the lens formula, collecting their data for different object distances. You'll get corresponding image distance. They can work out the focal length using this formula here. So there's lots of nice investigative work that students can do, quantitative and qualitative. Now we can have some fun with them. Here we got a lens, focal length 9.5, and so therefore twice focal length is about 19.5 on that side. If I place my candle between focal point and 2f, my rule says I'll find the image beyond 2f, and I bring it up, and sure enough, there it is. It's real, it's enlarged, and it's inverted. So the image really is there. If I take a second lens, I can use that as my lighted candle, and I can see where will I find the image of that image. Well, that depends on the focal length of this, etc. I'm using the same focal length, 9.5, but you can use a different focal length. I should be able to pick up its image. It's beyond 2f, I should find it between f and 2f on this side. Well, it's going to be somewhere here. Let's take it away, coming back, and voila, there it is. And what do I note? It's the right way up. That's exactly what I expected. So in other words, my light has come from there, through here, create an image, I'm taking that and I'm putting it there. This is the principle on which a microscope works, a telescope works. All they've got is two lenses, and we just got to get them the right focal length, and we just adjust the positions and we can get it back in focus. Right, and then finally, for you, the teacher, a very important part, how can you help this book knowledge that the children have got become real knowledge? What relevance can they find in everyday life? What kind of projects can they go and do with respect to it? Plenty. Let them go home, try and identify as many things as possible that have got lenses in them. They can do experiments with spectacles, find out what's the focal length of a pair of spectacles. Are reading glasses got a different focal length to the distance vision? They can build microscopes, they can build telescopes. You've shown them the basics. All they need to do is find a way of mounting those lenses. And then I've shown you a lot of ideas today. You've got a lot of ideas. Send them in to me and I will find ways of sharing them, and I'll give you proper acknowledgement for it. If you've got any comment or questions, email me.